Okay, here we're back together. Let's do the second half of the chapter 2 review. So we're in the BJU Press Pre-Algebra book on page 105. I'm starting with number 27. Write each word phrase as an algebraic expression. Number 27, it says the product of -9 and n. This means multiply. The product is a multiplication, so -9n. 28. A third of the difference of x and 4. So we have to go and write down the difference of x and 4, which would be x minus 4, that's subtraction. And a third of it would divide it by 3. Number 29, 23 increased by twice m. So we start with the 23, increased by is adding, twice m means multiply m by 2. Number 30, 64 less the product of 5 and p. 64 less the product of 5 and p means multiply 5 and p. So minus 5p. Number 31, the distance between 12 and a. Distance between tells you find the absolute value, which is the distance away from 0. So the distance between 12 and a, or the absolute value of 12 and a, 12 minus a. Number 32, the quotient of z and v decreased by 28. So the quotient of z and v is set off by the comma there. So they want us to do division z divided by v, that's what quotient means, and then minus 28. Number 33. Write an expression for each person's age if Angie is A years old. So A is Angie. I'm just going to jot that down. Okay, letter A, Leah, who is 5 years younger than Angie. So Angie minus 5. B, Jen, who is 2 years older than half Angie's age. Okay, so we're going to have to take half of Angie, so A divided by 2, and then it's 2 years older than that, so plus 2. If n represents an even integer, write an expression for the next 2 even integers. So we know that when we have even numbers, it's already starting even, right? So if n is already starting even and we add 2 more, every time you get an even number, you have to add 2 more. So n plus 2 would be the first even one, and then n plus 4 would be the next even integer. State the number of significant digits in each measurement. A snake that is 10.7 feet long. Okay, so I have 1, 2, 3 significant digits. Number 36, a bacterium that grows for 2,014 minutes. Okay, so I have 1, 2, 3, 4 significant digits. 37, a coin that is 0 and 1,790, let me see if I can get this right. So this is millions. Okay, in this one, you're going to count the zeros that are at the end of the decimal number, but not at the beginning. So 1, 2, 3, 4 significant digits. Number 38. A state that is 600 kilometers wide. Okay, so we're just going to count the 6, 1 significant digit. If you were having any trouble with that or you don't know where I got those, it tells you right here to refer back to section 2.5. And in section 2.5, there is a chart And let me see, it is on page 91 at the top with significant digits. There's a box. It says significant digits in blue, rule 1, rule 2, rule 3. So you have to memorize those in order to do well on those significant digit ones. Number 39, write each number in scientific notation. Okay, so we have 6 zeros and then a 38. So in order for it to be in scientific notation, I need to have a number in between 1 and 10, but not equaling 10. Okay, so that means I'm going to have 3.8. I'm going to put my decimal right here where that arrow is. 3.8 times 10 to some power. So if I'm putting my decimal in here, I'm going to count how many hops it would take me to get over to where it originally was. 1, 2, 3, 4, 5, 6, 7. So I'm going 7 hops to the left, which is how I know it's a negative 7. Number 40. So I have 749 million. Okay, so in scientific notation, again, I need a number between 1 and 10, but not equal to 10. So basically, digit 1 through 9 can be in the beginning of my number. So 7.49 is what I'm going to need here in order to have my decimal point there. And then I'm going to be multiplying by 10 to a certain power. So my decimal point, I need it to be between the 7 and the 4, but it was originally at the end. So let's see how many humps it takes to get there. 1, 2, 3, 4, 5, 6, 7, 8. To the right. So it's 7.49 times 10 to the 8. Number 41. Write each number in standard form. So we have 3.95 times 10 to the 12th. Okay, so that means I need to move my decimal point 12 to the right because it's a positive 12. Okay, so I'm going to write down the 395, and then my decimal point was here. So 12 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need to fill in each of these humps with a 0, and then we'll go back and add in the commas. Okay, number 42. We have 9.8 times 10 to the negative 9. Okay, because it's a really small number, a negative, I'm going to write the 9.8 here. And I need to go 9 to the left because it's negative. So it was originally in between the 9 and the 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then any place that has a hump, I'm going to add in a 0. So you should have 1, 2, 3, 4, 5, 6, 7, 8 zeros in front of the 9, 8. Number 43. Write through 36,360 feet per second, the maximum speed of the Apollo 11 spacecraft during its return from the moon, in scientific notation. So 36,360 feet per second in scientific notation. Okay, so again, I need a number between 1 and 10 not equaling 10. So 3.636 times 10. So here's where I need it to be. It was originally at the end. How many do we have to go? 1, 2, 3, 4. And we went right. So times 10 to the 4th. Don't forget your units. You should always have units in word problems. Number 44. Light in a vacuum can travel 1 meter in approximately 0.0033 microseconds. Use both scientific notation and standard form to express this time in seconds. So we've got 0.033 microseconds. What is that crazy symbol? Let's see, it looks like this. Microseconds. Okay, So scientific notation would need a decimal right here. So that would give us 3.3 times 10. 1, 2, 3. We had to go 3 to the left. So that one's scientific notation. What is it saying here? Use both scientific to express this time in seconds. I'm not seeing why they have a -9. I must be missing something. Let me see here. So 44. It's telling me in my notes here, in my teacher notes, what a microsecond is, which I had no idea. Okay, so let me go back here. Let's redo this. Okay, so it says a microsecond is 1 times 10 to the -6 seconds. So we're going to take this original number that they have in microseconds, but they're saying a microsecond is 1 times 10 to the -6 seconds. So I'm just substituting like this symbol here. Microsecond equals 1 times 10 to the -6 seconds. So when they wrote this down, 0.0033 microseconds, I just substituted this down here for microseconds, since that's what a microsecond equals. Okay, now let's try it again. So we still want to have our decimal be here, which is going to give us 3.3 times 10 to the some power that we don't know yet. So if our decimal is here, we have to go 1, 2, 3 to the left, but we were already -6 to the left, which means the -3 and the -6 is going to make us be -9. So this is scientific notation. Standard form, I'm going to put my 3 over here because I know it's going to be a really small decimal since it says -9. It was in between the 3 and the 3. I need to go -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be 8 zeros in front of the 3 seconds. Number 45, round to each place value. So we have 82,487 and 596 thousandths. So A, the number, if I'm going to round to the thousands, that means I'm rounding this. The 2 is in the thousands place. Okay. So I always keep everything to the left of the same. Once I get to that 2, I'm going to pause. I'm going to look at the number next to it. It's a 4. That means it's going to stay a 2. Letter B. Okay, the ones. So now I'm looking at the 7. So I'm going to keep the 8, the 2, the 4, 8. When I get to the 7, I'm going to pause. And I'm going to look at the number to the right, which is a 5. That's going to round my 7 up to an 8. Letter C, tenths. Okay, so the 10th spot is this 5. So I'm going to keep everything to the right of that the same. When I get to the 5, I'm going to pause. The 5 is followed by a 9, which means it's going to round up to a 6. Letter D, hundredths. The hundredths is the 9. Okay, so we keep everything to the left the same. We get to the 9, we pause. Look to the right, it's a 6, so it needs to be rounded up to a 10, which actually is going to back this up and make it be a 6. Don't forget that they told you to round to the nearest hundredth spot. So that means you must have a digit in the hundredth spot. So we need to add a 0 in that case. Number 46, estimate by rounding each number to its highest place value. So we have 72 plus 89, highest place value. So we're going to have 70 plus 90, or 160. 47. Okay, highest place value is going to give us 8,000 minus 7,000. 1,000 is our estimated answer. 48. Okay, highest place value. So that means we're going to have 8,000 plus 600 minus 2,000. And we'll end up with 6,600. 49. Estimate each product or quotient. So we have 517 times 28, which is really close to 500 times 30, or 1,500. Number 50. So we end up with 500 times 700, or 350,000. Number 51. 342 divided by 61. So remember these, when you do division, you're not necessarily rounding to the next 10 or 100 or something with a nice pretty zero at the end. Every time you're going to be rounding to the numbers that are compatible, so that it'll make it really easy to divide. I would probably see that this is pretty close because it's 61. I'm going to say let's round this one to 60. And then 342 is really close to 360, which happens to be a multiple of 6. So that's why I picked it. And then we can cancel out these zeros and we can divide and get, it's an estimate of about 6. So number 52, we have 9,859 divided by 192. I think in this case, I'd probably just go straight to the nearest 1,000. So 9,859 is going to be 10,000 divided by about 200. So these zeros will cancel, and 2 goes into 150 times. All right, guys. Thank you. So that's that, and we should be almost ready for our test.